So just a little refresh. You don't have to write any of this down. It's all in your packet. If I want to prove two triangles similar, I have three different ways. Those ways. Mike? Okay, I got angle, angle. Prove two pairs of angles congruent. Nick? Side angle, side, similarity, which says a pair of angles need to be congruent. Sides around it need to be in the same ratio. And then there was a final method. Well, side, 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 similarity, which said all three pairs of sides need to be in the same ratio. Which one up here did we mainly always use in a proof? Angle, angle. Okay. Last day before we started reviewing for the midterm, we said if the triangles are similar, what do you know about the sides? They're in the same ratio. They're in proportion. And remember the reason we gave in a proof that said once the triangles are similar, why the sides were in proportion. Anybody remember the reason? Emma, C, SSTP. Corresponding sides in similar triangles are proportional. Today, we go one more step in these proofs. So yes, you are going to prove them similar by angle, angle. Tell me the sides are in proportion by CSSTP. One extra step after this, and that is it. Okay? Ready to get this train rolling? Okay. And again, you don't no need to copy this down. If I said solve for x, what would you guys do? Cross multiply. You probably never realized this. No one ever told you, but what you're cross multiplying has a name. What you cross multiply, the 2 and the 9, actually has a name. Those pairs have names I'm going to show you today. First one, the A and the D. The A and the D value. Right here, if I write it as a proportion, the A and the D value are called your extremes. Extremes. Again, A and D right here. Those are called my extremes. And from today's title, I'm sure you can guess what B and C are going to be called then. Those are my means. Yes, B and C are the means. How do you remember which one's which? And this is not my method at all. A couple of years ago, a kid said, hey, you can remember you do extreme downhill skiing. I don't know, downhill. That's how he remembered it. So I was like, fine, I'll keep it. So extreme downhill skiing. All right. After you multiply the extremes and the means, what do you usually do with them? Set them equal, right? You set them equal. That's what the theorem says. Ready? What's the result called when you multiply again? Like sum is when you add. Product. So that's the first here. Product of the means equals, what do you always set it equal to? The product of the extremes. Yep. Nope. So there's the new theorem today that's going to finish off our proof. Product of the means equals product of the extremes. Now, one second, Cameron. I allow you to abbreviate a ton in here. All right, a ton. This is one I'm not going to allow to abbreviate. So if I see in your reasons column, POM equals PO, we are going to have an issue. Okay? There's no abbreviation here. POM equals PO is not going to fly with me. All right? Go ahead, Cameron, your question. No, that is nope. Good question. That is not related. No. Okay, not related. All right, let's use it now. Let's use it. I'll let you fill in your diagram with whatever you need to. I already filled in the given, so that's all done. I got these two sides congruent. And I have right angles at TER. And I have ADT. as a right angle. Perfect. All right, so here we go. I see the proof statement. I'm multiplying segments together and saying they're equal. So automatically I'm thinking, ready? Similar triangles, similar triangles. Multiplying to segments. Here's the problem. Everyone look at the diagram. Do you see multiple triangles in that diagram? Oh, I see a ton. And now what we have to decide together is, well, which two do you prove similar then? Ready? Use your proof statement. What's the first segment that's listed in the proof statement? E. First segment that's listed in the proof statement. ER. Everyone locate ER on your diagram. ER, is that a full side in one and only one triangle? What triangle is it? That it's a full-sided. TRE. So it looks like we found the first triangle, didn't we? Well, where's the other triangle? Let's keep going. What's the next segment listed in the proof statement? ER, then it's AD. All right, well, look at AD. Ooh, I'm going to run into a problem because you see it's a full side for the one on the right and a full side on the one on the left, and I'm not guessing. Do you see how AD is not going to help me out too much? All right, let's keep rolling. TE. TE is the next one. Oh, I already have that triangle. No big deal. Last segment. What's the last segment that's listed? DT. Whoa, DT combined with that AD that I couldn't use. Do you see where the last triangle is? Where is it? Triangle ADT. So we got the two triangles now that we're going to prove similar. By what method, probably? Angle, angle. I need you to find two pairs of angles right now that are congruent. One pair. Hopefully it's not that bad to see the first pair. Let's see our old numbers back again. 20. Because they are right angles. Usually you'd have to tell me the right angles, but I already gave it to you. You're welcome. So now you just have to tell me that they're congruent. So TER, congruent to ADT. Right angles are congruent. All right, use your givens. Use your givens. You're going to tell me, Will? Settle down. The right angles. Where are the other pair of angles then? Use your givens. There's one given we haven't touched yet, and it will lead you to it. 18. Ooh. How long we've been in this class? Come on. I like angle R, but I do not like angle T. Thank you. There we go. Those two angles. So angle R is congruent to angle ATD. Hugh knows, or he wouldn't have given it to me. No, nobody cared. Nope, just stop. We know you know. 6. Why does Hugh know? There you go. This stuff's never going away, is it? Nope. Okay, get through Friday. No proofs next unit. Really? Really? Emily. No, you do not, because this works for any triangle as long as two sides are congruent. Next unit involves the old sine, cosine, tangent stuff. Yep. It's a lot. It's very heavy algebra next unit. Very heavy algebra. No proofs next unit. No proofs. All right, let's keep moving. Let's keep moving. We got to finish this unit first. We have two pairs of. All right, hey, we got two pairs of angles. What do we know about the triangles? They're similar. Yep. It's all right. First day back. It's okay. Happens. Triangle RET. Similar to. Let's see if I go RET. TDA. How's that look?
No, because T would be the last. No, it'd be the second letter. TDA. Yeah.
C's in the middle. D's in the middle.
No.
A is on the opposite.
No, I am.
Wait,
In
no.
it.
Oh, it looks like a K.
Wait,
With the E's,
flip
man.
it. No, T is the second. I don't see. I'm just gonna trust you.
Okay.
I usually draw them out.
Okay, that's fine. You can list it in different orders. That's fine. That's fine. Just depends on what triangle you start with. All right, here we go now. Now that you know the triangles are similar, what do you know about their sides? Not ready to write that yet. We're not ready to write it. They're in the same ratio. So now we have to come up with that ratio. And we'll make it very easy on you. There's no guessing games. How did they get ER times AD? They cross-multiplied, right? So if I'm going to put ER first, only one spot AD can go. And where is it? Bottom right, because I'm going to cross-multiply those extremes. Everyone see that? If you didn't want to put ER there, fine. I don't care where you put ER. AD's got to go diagonal from it. And then TE and DT can go in either spot. And what reason is the sides in the same ratio? CSSTP, see how we're building on before the midterm? And now we cross multiply and say that yes, ER times AD is in fact equal to TE times DT, because now we have a theorem that says product of the means, and again, I don't care what order you put them in, product of the means equals product of the extremes. Prove them similar, get the sides in the same ratio, and then we have one last step with the means and extremes today. All good? I only have one more proof for you, and that's it. I'm done for today. I'm not dragging this out, so you can either start the algebra problems on the back of your assignment sheet or the homework tonight, which has more algebra as well. All right, here we go. One more. Can you guys identify the two triangles I need to prove similar here first? See if you can find them on your own in your group, whatever you prefer. You see the segments I need. Can you find me the two triangles? Anybody want to tell me the two triangles they found? Will, go ahead. You can go on this one.
RQC.
Okay, hold on. RQC. Ooh, this big dog. All right, and?
AQ.
Yep. Look at those, huh? All right. Let's prove them similar. Only thing I gave you was it's a parallelogram. Excuse me, it's a parallelogram. PQRS. Ooh, parallelogram properties. Yep. Not going anywhere. All right. Any properties you want to apply to find a pair of angles for me? Let's roll with 17. Yes, it is. There we go. So angle. Thank you for not calling it angle R and P max. So SRQ congruent to QPS, QPA, doesn't matter. How's Max know that? That true fact that just came out of his mouth. 14? Thanks, Emma. How about 5?
Parallelogram implies opposite angles.
Oof. Where are those other angles going to come from? There's really no other given, so you've got to keep building that it's still a parallelogram. All right, Cameron, I'm ready. Or do you and Sean want to partner up here? No? Okay, go ahead, Cameron.
Okay, can you say that RS is parallel to QP and then do like alternate interior?
Yes and no. You can say RS is parallel to QP, but the alternate interior angles you want, I need to say something else in between. And I'll show you why. Oh, stop. Oh, thank you. RS is parallel to QP. I got that. Because parallelogram implies what there, Cameron, if you're going to use it? Opposite sides parallel. Now, what were going to be the alternate interior angles you wanted? This one right here?
Yeah.
With what other one? This one? Okay, they are alternate interior and they are congruent, but not from these parallel lines. I need to extend RS to RC. So now in step 4, if you wanted that, you could say RC now is parallel to QP. Yes. Because what was the theorem? Anybody remember that one? We use it from time to time, not as much as we should. Mike?
Extensions of parallel lines
On fire today. Extensions of parallel lines are parallel. Yep. Now you can say the alternate interior angles are congruent from what Cameron gave us. Bless you. So angle C is congruent to, what do we call that other one? PQB. How do you start this reason out? Not parallelogram. Parallel lines imply what? Alternate interior angles congruent. Yep. Now, I don't know if anybody else saw it. Did you need to pick those alternate interior? Anybody see the other pair of alternate interior that you could have used instead of those? Anybody see these right up here? Okay, but instead of having RS parallel to QP, you would have had what two lines parallel? If you wanted these two alternate interior angles, what lines would need to be parallel then? SP and RQ, okay? All right, let's finish it. Tell me the triangles are similar now. Oh, hey. Oh, okay, maybe not. Triangle RCQ. All right, I'm going to give this another shot here, Cameron. RCQ. P, Q. All right. Angle, angle. And now, again, this is your second time doing this, but first time in the unit. Be careful when you write your proportion. Make sure you are cross-multiplying the means and extremes. So the extremes here, I'm going to put QC and QP. Make sure they are diagonal of each other. And the other two, AQ and CR. CP, C, ooh, almost did it. Whoa, settle down, everybody. CSS, TP. And then you guys can finish it up. Start, there's a lot of algebra I assigned tonight, so if you want to start on some of those. Answer keys are already posted on Aspen, except for the problems behind the assignment sheet. So we'll move around. Call me over if you want help or if you want me to look over anything.